Just now we have analyzed that actually for fixed point during the operations, we need to consider the diversity of the image on each face. In the following, we use a question for you to show how to find a fixed image. It is still related with a regular hexahedron. On each face of regular hexahedron, we can draw a diagonal line on it. Then on each face, I simply draw a diagonal line for direction. How many different solutions are there? Everyone will be thinking for regular hexahedron, how each face would look like. It is a square. Square can draw such kind of diagonal. Can also draw the diagonal this way. Each face, it contains two different choices. We can refer to the two coloring problems. Again, think of diagonal lines and the two colorings. Do they contain certain differences? What we need to look at it is fixed image. Fixed image simply means after the rotation, it is still it was. If it was just about coloring, after coloring red over this face, after rotation it is still red. But for a diagonal line, if we draw a diagonal line this way, then rotate 90 degrees, the direction of the diagonal line may be changed. It should not be what we call a fixed point. Therefore, although we may refer to the two coloring, for this kind of special question, we need to consider the diversity of each colored face need to be stated if it produced a fixed image for real. For fixed permutation, rotation, positive, negative 90 degree and 180 degree, and also edge center to edge center. For symmetry axis, we list all these permutation groups. This permutation group and what we have previously raised the question is exactly the same, but we need to consider whether it contains fixed images, which means after it was rotated whether it will be changed. How many fixed points are there? And the starting point, the fixed permutation is very easy. Every point is fixed. Therefore, it is a one-order cycle. In total, there are 6. Coloring is 2 to the power of 6. Whereas for face center to face center, we need to consider carefully. Face center to face center, a face on top and a face below, they have rotated 90 degrees respectively. And this time, if there is one diagonal like this, passes through it, but after rotating 90 degrees, it will become another diagonal line. The image will definitely change. Therefore, the number of the fixed point is 0. And this time, everyone may need to pay attention. We may not only directly look at its cycle structure by applying Polyhedron theory. We need to carefully analyze what are the actual situations for now. For 180 degree rotation, rotating 180 degrees is actually like this. After rotating 180 degrees, it is still something like this. Therefore, it contains fixed images, whereas the number of fixed images should be equal to 3 multiplied by 2 to the power of 4. For edge center to edge center, something applies. The diagonal line after the rotation, it is still the original diagonal line. Therefore, its fixed image is still solved by using the original number of cycles. 6 times 2 to the power of 3 for diagonal line, it is still the same diagonal line. Therefore, its number is 8 times 2 squared. Then we will get on the right side a series of numbers, accumulate them all up. Then divided by all the permutation number 24, what we get is the answer for this question.